Hi, this video is going to go through guided notes on graphing quadratics in standard form. So in Friday's Google Meet, we did vertex form, which was similar to what we saw with transformations. What's different with standard form is literally the way it looks. So it's still a quadratic, it's just going to look a little bit different. So standard form of a quadratic function is y equals ax squared plus bx plus c, where a, b, and c are real numbers. Notice, you know it's still a quadratic because of the square, so you know the parent function is a quadratic. It's just a different form than what we saw with transformations. It has the same properties as a quadratic in vertex form, meaning the number in the front, or a, so whatever number is in the front of x squared, if that number is positive, the graph opens up and has a minimum. So it looks like a U, like an actual U. If a is negative, that number in the front's negative, just like with transformations, that graph's going to open down because it's reflected. So it's going to be an upside down U. And it also has the same effect as in stretching and compressing. If a is a fraction between 0 and 1, it's going to make it wider because it's vertically compressed. And if it is a number greater than 1, it's going to appear narrower, or like a skinnier U, because it's vertically stretched. So that's nothing different from vertex or transformational form. The vertex, so this is still a parabola, so it still has a vertex. It's going to be a minimum or a maximum based on if it opens up or down. So depending if it opens up, it'll have a minimum. If it opens down, it'll have a maximum. But the formula for the vertex, it's still a point. To find the x-coordinate of the vertex, you're going to go back to the original, and we're going to do negative b. So whatever this number is, negative b divided by 2 times a, whatever that number is in the front. And then to find the y-coordinate that goes with it, we're just going to plug that in. So whatever we get for negative b over 2a, we're going to plug in the original for all of the x's. And then the axis of symmetry is the same as vertex form as the x-coordinate of the vertex. So for here, the axis of symmetry will be negative b divided by 2a. Or whatever you got up here for the x-coordinate. Because that axis of symmetry always goes through the x-coordinate of the vertex. In standard form, something interesting and special about standard form, the y-intercept, or where it crosses the y-axis, is always c, the number in the very back. So that's always going to be the y-intercept. And then domain and range, the domain for all quadratics is all real numbers, or negative infinity to infinity. And then the range is going to depend on if it opens up or down. So if the U opens up, that's if a is greater than 0. So I have a U that looks like this. This minimum, I don't want to say k here, but it's going to be the y-coordinate of the vertex, whatever that is. So this point is going to be some point. I'll just call it hk. Whatever that vertex is. So if this parabola opens up, that means the lowest y value is k, and it's going to go up forever. So my range is k to infinity. And just the opposite, if it were to open down, that point, that vertex is a maximum, or is the highest point. Is the highest point of that, so the negative infinity up into that k is the range. That is if it opens down. All right, let's just go through a few examples of looking at these properties that we just went over. Notice these examples are both in standard form. So for the first example, I'm just going to kind of write it in standard form. Remember, standard form, I'm going to write it above here, is ax squared plus bx plus c. Okay, sorry about that interruption. I paused for some announcement they made over the loudspeaker. So I just wrote standard form above the example. That way you can see what a is, what b is, and what c is. So for this first example, a is 1, because that's what number is in front of x squared. B is negative 2, and C is negative 1. So let's go through these properties knowing A, B, and C and seeing my quadratic that's in standard form. So open up or down. So if you go back to the previous page in notes, it depends on A if this opens up or down. This one, A, is positive, so it's going to open up. For the vertex, again, if you flip back to the previous page, the formula for the x-coordinate of the vertex is negative b over 2a. And then to get the y-coordinate, we're going to plug that in. So let's do negative b over 2a first. So if I do negative b divided by 2a, well, negative b, or b in our problem is negative 2. So that means I'm going to have negative 2. That'll become positive 2. And then a in my problem is 1. So negative 2 becomes positive 2. In the bottom, 2 times 1 is 2. So that's 2 over 2, which is 1. So the x-coordinate of my vertex is 1. To find the y-coordinate, I go back to the original. So the original is y equals x squared. So instead of x, though, we're going to put in that 1 minus 2x. Instead of x, we put 1 minus 1. So if I simplify that, I get 1 squared is 1. 1 minus 2 is negative 1. Negative 1 minus 1 is negative 2. So the x-coordinate of my vertex was 1. The y-coordinate's negative 2. That means my vertex is at 1, negative 2. That was a little bit of work, but at least some of that work got me to my next point. The axis of symmetry is always the x-coordinate of the vertex. So here that's going to be x equals 1. Domain, that's easy. Always negative infinity to infinity for these guys. And then range, let's think about the range. This opens up. So this graph looks something like this. It's going to open up. So that means my vertex at 1, negative 2 is a low point. So that means the lowest y value will be that vertex, which is at negative 2. So the range starts at negative 2 and it goes up forever to infinity. Now that we've completed one example, go ahead and pause the video and try the next one on your own. And then when you unpause it, I'm going to show you the solutions. Hopefully you had enough time to, you paused it long enough to complete that example. As you can see, I filled in the answers. So go ahead, check your answers with this answer and pause the video again. All right, let's graph these parabolas in quadratic form. I'm going to do one, then I'm going to have you try the second one on your own. We're going to do the same steps as vertex form. That should actually say standard form there. So same steps, meaning we're going to find and plot the vertex first. Then we're going to make a table around the vertex. And then we'll plot the points from the table and sketch my parabola and my axis of symmetry. So let's go. Let's find the vertex first. So the vertex, I'll do it up here in the margin. I'm going to do negative b divided by 2a. So for us, b is 4. There's b, 4. A is negative 1. So if I simplify that, I get negative 4 over negative 2. That's positive 2. And then to find the y-coordinate, I'm going to plug that 2 into the original. Negative 2 squared, or 2 squared is 4, and make it negative, so that's negative 4. 4 times 2 is 8, so negative 4 plus 8 is positive 4, and then 4 minus 3 is 1. You can also use a calculator. So that's my vertex. I'm going to build a table around that vertex. My vertex is at 2, 1. And I'm just going to pick 2 points below and 2 points above. And I'm going to plug those x values into the original to figure out the y. So if I plug 0 in, back to this original problem, if I put 0 in for these x's, that's going to be 0 plus 0 minus 3, so that's negative 3. if I plug a 1 in, I square the 1, that's 1, make it negative, so negative 1, plus 4 times 1 is 4, so negative 1 plus 4 is 3, and then 3 minus 3 is 0. You can also use a calculator. And nice thing about these quadratics is they're symmetric around the vertex. So if the points 1 away on the left are at 0 and negative 3, that's going to be the same for the points on the right. So they're my points I'm going to plot. Let's go ahead and plot them over 2 of 1, 1, 0, and 3, 0, 4, negative 3. It's down here. That's negative 2, sorry. I can't really see these. This is negative 3. 1, 2, 3. Just kidding. One more try. That's 1, 2, that has to be 3, and then at 0, negative 3. And just a quick check, I'm going to sketch in my axis of symmetry just to see that, yeah, that looks symmetric. That axis of symmetry is at 2. I'm pretty confident in that graph. Go ahead, pause the video and try the second example on your own, and when you press play, you will see the solution. So as you can see, the solution for 2, your vertex should have been negative 3, 3. And I put that in the middle of the table, and I built my table around that vertex. When I graph those points, it's U-shaped, it's skinny. We knew it would be skinny because of the 3. And it looks symmetric, pretty symmetric around that axis of symmetry.